that a pregnancy lasts less than 258 days. So less than 258, we draw a line at 258, and we shade in the less than. Okay, let's go to StatCrunch. Mean of 266. So this is good. This is the easier part of this problem. And we want less than 258. All right, so we put in the mean of 266, standard deviation of 21, less than 258. So roughly 35%. Okay, I think 4 decimals, 3516. Okay, so far this is a straight normal calculation. Part B is when we're starting to deal with a sample mean. Oh, if you want to be a forensic, the program that my wife and I watched a little bit last few months is Murdoch Mysteries. You can think of it as a Disney version of CSI Toronto 1899. It's very cute. You can tell it's Disneyized. Everybody's riding horses, but there's no horse poop anywhere on the roads. It's got to be Disney. Okay, what is the probability that a random sample of 19 pregnancies? Okay, so here we have to do a calculation. Here we have to do a calculation with a calculator. The difference between part A and B. Part A, the mean was 266, and the standard deviation was 21. Part B, since it's the average of 19 pregnancies, the mean is still the same. If each one averages 266, then 19 of them will still average 266. The difference is that the standard deviation for means is the original divided by the square root of how many you have. Here we have 19 pregnancies, so it's 21 divided by the square root of 19. And here we need to use Excel or a calculator. See, 21 divided by the square root of, nope, that's not what I wanted. 19 square root. Okay, 21 divided by the square root of 19, I believe, is 4.81773. So I'm going to write this out to a lot of decimals. MyStatLab wants 4 decimals of accuracy, so I'm going to make sure I have at least 4 digits. Just to check, let me go to Excel to make sure this calculation equals, what was it, 721 equals 21 over the square root of 19. Okay, so this is the new standard deviation. Okay, so this is the mean, still 266. This is the new standard deviation. So let's go back to StatCrunch. The mean is correct. The new standard deviation is 4.81773. And the problem is still asking for less than 258. So now the difference between part B and part A. Part B is the average of 19. That means the standard deviation is less. So when we compute, we get a different probability, 0484. Okay, let me get to, let's see. Okay, that's a very good question, Becky. Why is the mean still 266? So let's say animal number 1 is pregnant, has an expected length of pregnancy of 266 days. If we take 18 other animals, each one of them also has an expected average of 266. So if each of the animals averages 266, then all of them together also average 266. So the mean does not change no matter how many you have. What changes is the standard deviation. Okay, so 11 through 14 are definitely harder because it involves a second step of work. It involves calculating this new standard deviation. The random sample of 28 pregnancies. Now that's going to be almost the same, but instead of dividing by the square root of 19, we have to divide by the square root of 28. So, don't like that color. Let's go for something nice and bright. So the mean still stays the same at 266. Doesn't matter whether we have one of them, 19 of them, or 28 of them. Mean's still at 266. The standard deviation was the original, 21, divided by the square root of 28. It's always divided by the square root of the number of data values. This is the average of 28 data values. So I'll go to equals 21 over square root of 28. I actually use Excel for calculations a lot more than a calculator. You can type it in and I can see what I'm doing. So the new standard deviation is 3.968627. I carried it out to a lot of decimal places. Now once we know the new standard deviation, it's still a mean of 266. Enter the new standard deviation of 3.968627. We're still calculating the chance of being less than 258, and it's roughly a 2% chance. 0.0219.